In this video, we're going to look at how to find the equation of a line. To do this, you always need two pieces of information, but those pieces of information can vary from one question to the next. The very simplest way of arranging this is if you're given the gradient and the y-intercept. If we know that the gradient is 3 and we know that the y-intercept is -2, it's a very simple matter just to substitute those in to the correct places in the general equation of a straight line, and we have our answer. If we develop it a little bit further, such that we're not given the y-intercept, we're given still the gradient and some point on the line, what we can do here is we know that the gradient is 2, so we know from y equals mx plus c, we know that y equals 2x plus c. But we can now bring in this information here. This is an x value, this is a y value, and so it follows that 4 must equal 2 times 1 plus c, just by substituting in x and y into the appropriate parts of the equation. If we simplify that a little bit and solve the equation, we discover that c is 2. It's a coincidence that these have the same value. Now, in the first example, when we knew the gradient and the y-intercept, it was easy. And we're now back in that situation. We know that y equals mx plus c. We know that the gradient is 2. We know the y-intercept is 2. And we're finished. It could be developed further. Instead of being given a gradient and a point, you might just be given two gradients, and this takes a little bit more thought. It's helpful to draw a sketch. We draw a quick sketch of what we've got here. We've got -2, 5, perhaps somewhere about there, just roughly. And we've got 3, 15, perhaps somewhere out there. And we've got a line between them. Now that should make you think of the possibility of working out the gradient. As we've seen in a previous video, the gradient is the change in the y values divided by the change in the x values. So if we start with this point and finish with that point, we've got y values of 15 take 5 and x values of 3 take -2. So that's 10 over 3 plus 2 is 5. The gradient of this line is 2. And we know, because it's a straight line, we know that y equals mx plus c. So we now know that y equals 2x plus c, because we've discovered the gradient here. We need a value for x and for y, and we've got a free choice. We can either use that pair or we can use that pair. The argument for this pair is the numbers are a bit smaller. The argument for that pair is that they're all positive and they're easier. I think I actually prefer these ones. So what I'm going to do is I'm going to say that the y value is 15, 2 times the x value of 3, 15 equals 6 plus c, take 6 from each side, discover that c is 9, and so therefore y equals 2x plus 9. You can try this for yourself if you wish, with this point instead. You'll find that you still get c equals 9, you still get the same straight line. The last example I want to look at, you will need to have watched my video on perpendicular lines before you try this. But it starts in a similar way, in that you draw a sketch. 4, -2, let's think about this. Let's put it perhaps 4 comma negative 2 is perhaps roughly there. 8 comma negative 4 is perhaps roughly there. And this is the point that has been labelled A, and this is the point B. But we haven't been asked for the equation of that line. We've been asked for the equation of the line which is perpendicular, that is at right angles to AB, and goes through B. So what we're looking for is a line that does something like that. So I can see from my sketch I'm expecting a positive gradient. I'm expecting a y-intercept that's really quite negative. But I'm going to have to go into the algebra to actually work out what's happening. So I'm going to start with what I know. I'm going to start by working out the gradient of AB. And later on I'll think about the gradient of the perpendicular line. But that immediately causes me an issue with the way I write this down. I need to distinguish between the two gradients, so I'm going to talk about the gradient of AB. A subscript is quite useful. It's the change in y over the change in x. So I've got a change in y. Let's see. I think we'll say minus 4 take minus 2 over the change in x, 8 take 4. Now that numerator could easily go wrong. Negative 4 plus 2 ends up making a gradient of negative 1/2. Now this is the gradient of the line AB. If you've watched my video on perpendicular lines, then you will understand that the gradient of the perpendicular line, the red one, here must be 2. So the gradient, sorry, not the gradient, the equation of the perpendicular line, y equals mx plus c, is going to use that value for the gradient, but it also needs a point, x comma y. And it's really important now that you use the correct point. We want the line that goes through B, not the one that might go through A. It's got to go through B. So I've got to use 8 comma negative 4. The y value is negative 4. 2 times 8 plus c. If I take 16 from each side, then I discover that c is 20. And it now follows that I have y equals gradient of 2, y equals 2x minus 20. That is the gradient, the equation rather, of this straight line in red. And you remember I said it had a positive gradient, and I said that the y-intercept was going to be really quite negative, and that's what turns up here. These are skills that you've got to master.